Hi, my name is Dhinesh Raj, and this is my Dots and Boxes AI. Let's start by just showing a demo. 2 plies on a 2x2 board with the initials DR. So my strategy for this game is to stick to the edges and try to limit the amount of boxes that you draw 3 lines on, because obviously that 4th line is going to go to your opponent. And right off the bat, we see that AI has messed up. And let's go 0 up and 1 left. Okay, so this is not because I am a dots and boxes savant. It's due to my implementation of Minimax, which I will cover later. For now, let's look at the way I represented the board, scoring, and moving. So most of my code is held within this board class. And really the crux of it is this board array that contains a list of boxes. I handle moving in my main when the user inputs a move, and then I call my function addEdge. So addEdge mainly handles the string representation, as well as setting the boxes up, left, right, or down to true. These values all start at false when you generate a box, but slowly they will get ticked off. Furthermore, in my mark boxes function, I check for neighbors because there is cases where one line can result into 2 boxes being checked off, and this is also where I handle adding points. So I check if the box is marked, and if it's been checked as marked already, and then I add the points. So in my add points function, I also check if the person who got the box checked off is the AI or if it's the human, and this is where that is handled. Further into my board class, I have a board visual variable that creates a string with only just the dots in the beginning with the point values and the index inside the box. This is useful because instead of having to generate a new board and a new string every time you want to print it out, you can create one in the beginning and just edit it through addEdge. I also have find nth dot, which is useful for that string editing. I have valid move, which checks if a user's move has been done already. I have get open, which returns the open moves of each box. Is terminal, which checks if the game is over. And initials, which is for putting in that AI or the user's initials once a box has been checked off. My minimax is over here, and it starts by calling max value, which calls min value. So as you could have seen, it is quite easy to beat my minimax implementation. I believe that this is due to these comparisons right here and my misuse of the return values for minimum and maximum. I did follow the book's pseudocode, and there are some elements of it that are correct, like the comparisons to minimum value and to maximum value. These make it so that if a user gives the AI a box that has 3 edges complete, it will complete that 4th one. I also terminate once the plies has hit 0, and I decrement the plies here. Furthermore, I am checking every single open possibility and going to that amount of plies through these loops. So although my implementation of Minimax is quite similar to the book's pseudocode and does do some things correctly, I believe that these small missteps that I had with the usage of the return value for minimum and for maximum, as well as possibly the way that I used the evaluation function, led to this being a flawed implementation. I attempted to do this iteratively, and it worked to some extent. It was beating me quite often, but Minimax can't truly be Minimax without recursion due to the backwards propagation. So Minimax ends up returning an evaluation tuple that is the point value associated with the move that it wants to make, and that gets played into the game right there.